Students, today class we will discuss about the Jahn-Teller distortion and some solved questions regarding Jahn-Teller distortion. Let's see the first question. The correct statement about the CU-N bond distance in copper hexaamine complex. Normal, if it is regular octahedron, the metal is surrounded with 6 ligands with equal bond distance. Whenever the metal is having the d electron configuration where the electrons are filled unsymmetrically in the T2Z and EZ level, that actually leads to some distortion in regular octahedron. What is mean by unsymmetrical filling of T2Z and EZ? For example, if you see the metal as they have given copper, here copper is in +2 oxidation state. In the +2 the configuration is D9. If you see the copper D9 configuration, as you know, T2Z is providing 6 electrons and EZ is providing space for 4 electrons, where the 6 electrons completed and next 4 electrons are filling like this 1, 2, 3. Because it is having only 9 electrons. So 9 electrons, EZ is not filled completely. This is filled asymmetrically. Asymmetrically means either it should be 1 or it should be 3, odd number. If it is filled equally or if it is filled 4, then that is called symmetric. That means EZ1 is asymmetric, EZ3 also asymmetric. Now the copper 2 is having EZ3. That means it is having a asymmetric arrangement of electrons in its EZ level. Whenever the asymmetric arrangement, if you observe in EZ level, that leads to the strong Jahn-Teller distortion. If the asymmetric arrangement is there in the T2Z level, that leads to the weak Jahn-Teller distortion. Here, Jahn-Teller distortion occurs when T2Z, EZ are unsymmetrically filled. Okay. If that unsymmetrically filled is there in the T2Z level, like T2Z1 is unsymmetric, here the T2Z is having 3 electrons, 3 orbitals, where 1 is unsymmetric, 2 also unsymmetric, 3 will be the symmetric, right, symmetrically filled. Again 4 is unsymmetric and 5 unsymmetric, again 6 is symmetric. So whenever the T2Z having T2Z1 or T2Z2 or T2Z4 or T2Z5, these will show weak Jahn-Teller distortion. If T2Z is having like T2Z6 or T2Z3, this do not show Jahn-Teller distortion. Finally, Jahn-Teller distortion depends upon the electronic configuration of metals. Why this Jahn-Teller distortion arises? The Jahn-Teller distortion arises because this distortion basically lowers the energy of the complex, and further this leads to the increasing the stability of the complex. So to acquire stability, the unsymmetric complexes used to undergo Jahn-Teller distortion. So let's see the question here. Jahn-Teller distortion. What is the correct statement about CU-N bond distance? As I told earlier, if it is regular octahedron, the bond distance of all 6 ligands are equal. They are asking whether it is showing CU-N bond distance equal or different. You can observe the CU-N complex, that is a hexaamine complex, where it is having a 2 kinds of ammonia CU-N bond, that is these 4 nitrogens of ammonia are attached equatorially, and whereas the remaining 2 are present along with the Z axis, that is a axial. So this bond distance is not equal. Why? Because the copper exhibits the easy Jahn-Teller distortion. That means a very strong Jahn-Teller distortion. That's why it is showing a Z out Jahn-Teller distortion. So that means all the bond distance are not equal. This is wrong. Axial bonds are generally longer than equatorial ones. So these axial bonds are generally longer. Why? Because the Z axis elongated will happen. So those d orbital lobes which are having Z component is going to lowering the energy. That is called a Jahn-Teller distortion, stabilization energy. So here you can see these EZ orbitals are further getting splitted out, dx square y square and dz square. This dz square lowering the energy. This energy is equals to the Jahn-Teller stabilization energy. Okay. Next question. The set of ions expected to show Jahn-Teller distortion in their complexes. If they are asking whether the given ion is showing Jahn-Teller distortion or not, let's write the First we have to write the electronic configuration. In the case of titanium +3 oxidation state, the configuration is D1. That means it is having just one unpaired electron in its T2C level. That means it is asymmetric pattern of arrangement. So you can say it is showing asymmetric filling of electrons in its T2C level. That's why it shows weak Jahn-Teller distortion. Cu+2. This is showing, as I told you earlier, strong Jahn-Teller distortion because where the asymmetric filling is there in the EC level. Come to the high spin iron 3 complex. So here this is showing Jahn-Teller, this is also showing Jahn-Teller distortion. Let's see iron 3. What is mean by high spin complex? High spin and low spin complexes are formed on the basis of strength of ligand. If suppose the ligand is a weak ligand, so the difference between T2C and EC is very low. That means the crystal field splitting is very low. That means here the electrons can easily jump to the higher level, EC level, because here the pairing energy is very high compared to the del naught. So as I told you, this is high spin complex. High spin complex, the del naught value is low. So after filling of 3 electrons, the 4th electron will enter into the EC level. Then 5th electron, again 6th electron will enter into the T2C level. So here you can see pairing is not occurred in the T2C level. First electron enter in EC level, then only the pairing is going to occur. So that's why high spin complexes are generally formed by the weak field ligand and it used to form paramagnetic complexes. So you can see here the difference is very low. Now if you see, is it asymmetric pattern of arrangement EC level? No. In the T2C level, is it asymmetric or symmetric? It is asymmetric because it is T2C 4. So that means it is showing asymmetric pattern of arrangement in its T2C level. That means it shows a weak Jahn-Teller distortion. That means all the 3 are showing Jahn-Teller distortion. Option A will be the right answer. You can check the other also. High spin. High spin means high spin it will show, but nickel. Nickel is having D8 configuration. If it is strength of ligand is strong field ligand or weak field ligand, you can observe both the cases T2C EC as having symmetric pattern of arrangement in the case of nickel. So this do not show Jahn-Teller distortion. Similar way here, low spin iron also do not show. Low spin means it is strong field ligand. Iron is having D6 configuration. As it's a strong field ligand, the difference between T2C and EC is very high. So all electrons are tries to get paired up here only because the pairing energy is very low here. The pairing energy is very low compared to the del naught. So electrons tries to pair here itself. So it is becoming as T2C 6. So this is a symmetric pattern of arrangement. So there is a no Jahn-Teller distortion in the case of low spin iron complexes. So this option also wrong. Here also low spin is there. So option A will be the right answer. So they used to ask whether the given complex shows high spin or low spin complex or which will show strong Jahn-Teller distortion and weak Jahn-Teller distortion. Generally, the electrons, if it is unsymmetrically filled in EC level, that means EC1 or EC3 shows strong Jahn-Teller distortion. If electrons are filled unsymmetrically in its T2C level, that used to show weak Jahn-Teller distortion. Thanks for watching this video.